Hello students, in this video we are going to discuss about another important concept in chemistry, that is significant figures. Chemistry is largely an experimental science and it deals with the things that can be measured, as we have explained last. A number of common devices are used in the laboratories to make simple measurements. But every scientific measurement is limited. In each measurement, uncertainty should be reported carefully. So, if we repeat a particular measurement, we usually do not obtain the same result because each measurement is subjected to experimental error. Thus, in order to express the result of a measured quantity in a reliable form, we have to worry about the limitations. This is due to the limitation of skill and accuracy of the observer and the limitation of the measuring instruments. So, in order to avoid the uncertainty in the measurement, a new concept in the measurement is known, which is known as significant figures or significant digits. So let us discuss what is the significant figures. It can be defined as the significant figures in a number are all the certain digits plus one doubtful digit. Now what does this definition means? Let us discuss this with an example of a measurement. In order to understand this, let us assume that we want to measure the length of a rod that is shown here. This is a rod and we have to measure the length of this rod with the help of a scale. So here when we look at here, now this scale is representing here, that is actually the length can be 23. It can be 23 centimeter. But if it is slightly more than 23, if it is slightly more than 23 and less than 24, so it means that it lies between 23 and 24 centimeter. So with this scale, we cannot have a correct reading in the first place of decimal. That is, here by this scale we cannot have the first digit, first place of a decimal. That means if it is in between 23, if it lies between 23 and 24 centimeter, so we will assume that the value will be 23.5. That means in order to represent the first place of decimal point, this scale is not sufficient. That means we need a scale in which millimeters also represented. So here we will be just assuming that the first place of this decimal point must be the 5, that is 0.5. So we can make a guess here that it is approximately in the middle of 23 and 24. Therefore, the length of the rod may be reported as 23.5 centimeter. That is actually we are making a guess here. So in this case, 2 and the 3, these are called as certain digits. Certain digit means we can surely report that these digits are actually certain here. While the fifth 0.5, that is the digit 5 here, it is called as uncertain digit. Uncertain digit because this is actually we are making a guess and we are keeping that digit as 5 here. So here in this case 2 and 3 are the certain digits while the 5 is the uncertain digit. Therefore, different persons measuring the length of this rod may be reported different because someone can report like some of the can report this is as 23.4, someone will report 23.6 and even some can report 23.5. So that means by this scale only we could able to make sure that the starting numbers are right, but the first place of first place in the decimal point is made a guess here. That is, these are the here are the doubtful digit. So what actually the significant figures can be defined as in a number that are the all certain digits plus one doubtful digit. So here which one is the doubtful digit? For example, we are reporting the length of the rod as 23.5. So 2 and 3 are the certain digit. So this is certain digit, this is certain digit, and the doubtful. This one is the doubtful digit. So total how many digits are certain? That is 2 certain digit and 1 doubtful digit. So the number 3 is called as the significant figure. So significant figure for this value is 3. So we are actually just counting the number of certain digits and the one doubtful digit. So we will be getting a digit, that is a figure, which is actually called as a significant figure or the significant digit. So what we can say that if the length is reported as 23.5 centimeter, it means that 2 and 3 are the certain, while 5 is a uncertain digit. So in such a case, we can say that the significant figure will be 3. We conclude that the number of significant figures conveys the information that except the last digit, all the other digits are known with certainty. So in this case itself, from 23 value 23.5, that means except the last digit, that is 5 here, the other all digits here are actually known with certainty. Now, there are certain rules for determining the number of significant figures. So let us check what are the rules. Rule 1. All non-zero numbers are significant. All non-zero numbers are significant. So just now we have taken the example here, that is here the number 23.5. So 2 is a non-zero, 3 is a non-zero number, and even the 5 is a non-zero. That means this is significant, this one is significant, and this one is also significant. That's why here there are 3 significant figures. So in the first rule itself, we can say that all non-zero numbers are significant. Let us take one example here. So we'll be taking some of the examples like here. Now look at these example. First example, in this, let us tick out which are the significant figures here. Here, this 3 is a non-zero, 4 is a non-zero, 2 is a non-zero, 6 is a non-zero, and 9 is a non-zero. So total we have how many significant figures? 1, 2, 3, 4, 5. So here there is a 5 significant figure. In this case, there are 5 significant figures. Now, let us try for the next one. In this case, because all non-zeros are significant, so these all are non-zeros. So here, total how many figures are there? 1, 2, 3. So this is 3 is a significant figure in this case. So what about the last case? So can you make a guess here what will be the significant figure for this example? That is definitely it is 4. So let us check the answer for this one. That is 5 is the significant figure for this example, 3 is the significant figure for this, and 4 is the significant figure for this one. So this is the first rule, says that whenever we have any number, all the non-zero numbers are significant. So you can count all these numbers in the significant figures. So that is the rule 1. Now rule 2 says zeros between the non-zero numbers are significant. That means now we are talking about zeros. So just now we have discussed all non-zeros are significant, But even zeros can be significant, which is actually between the non-zero numbers. So the zeros between the non-zero numbers are significant. Let us take example for this, that is in this case. So when you look at here there is 1 0 and that is actually between the non-zeros, because here 340.6, that means this is a 0 and that is actually between the non-zero, that is it is between the non-zero numbers here 4 and 6. So at the time this 0 can be taken as significant. So let us check what are the significant figure for this one. 3 is significant because according to the first rule, 4 is a significant and even the 6 is significant. What about 0? Because 0 is between the non-zero, therefore it is significant. So what is the total number of significant figure here? 4. Now look at the second case. In this case, this is significant, this one is significant because of non-zero. And this 0 is between the non-zero, that is between the 4 and 2. So we can take this also significant. Next, so here also this is keep the dots or tick mark for the significant figures. And what about the 0? This 0 is also significant. So what is the total number here? 1, 2, 3, 4. 4 is the significant figure. So let us check the answer for these. That is, first case 4 is a significant figure. Second case 1, 2, 3. 3 is the significant figure. Here 1, 2, 3, 4. 4 is the significant figure for this one. Now next rule third says, the zeros preceding to the first non-zero numbers are not significant. Here again we are talking about zeros, that is zeros preceding to the first non-zero number are not significant. We are saying it is not a significant. Let us take example here, that is this example. Now look at this example here. First, when the number is given to us, like I'm writing this first number here. Okay, so when the number is given to us, first check according to the rule 1. So according to the rule 1, this is significant, this one is significant, and even this is significant. That is, all non-zeros are significant. And according to the rule 2, this one is significant. This is a 0 and that is actually between the two non-zeros. Therefore, this is significant. But here one more 0 is also there, that you can check here. Which 0? That is, I'm talking about this 0. This 0 is actually preceding to a non-zero number. You can see this is a non-zero number and this is a 0 which is preceding to this. So at the time this one is not a significant figure. So this one will not comes in the significant figures. Now count how many number of significant figures are there. Just check which one we have ticked. That is 1, 2, 3, 4. So 4 is a significant figure. So this 0 is actually, if it is in between the non-zero numbers, we can take it in the significant figure. Because here this is preceding to a non-zero number, that's why it is not a significant. So keep a cross mark here. Next example, in this example 4 and 2 are the significant, but 0 that is actually preceding to a non-zero is not a significant. So here there are two significant figure. So tell me, what about the case of the third example? Yes, this is significant, this one is significant, this one is significant. And all the other zeros are preceding zeros because these are not significant. So here there will be only 3 significant figures. Now let us check the answer for this. Here there is 4, here 1, 2, and here 1, 2, 3. So 3 is the significant figure here. That is the rule third says. Now rule 4 says all the zeros placed at the end or to the right of a number are significant if decimal point is present. What it means, like if I take the example like 402.0. So here let us check which are the significant figures. So as I told you, according to the rule first, all non-zeros are significant, and according to the second rule, zeros between the non-zeros are significant. So this is also significant, and here one more zero is there, this zero. Now when you look at this zero, it is on the right side of a non-zero number. You can check here, it is on the right side of non-zero number, that is 2, or we can say that it is at the end or the right of the number, and that is actually if the decimal point is present. And you can check here, there is a decimal point at the time this zero can be significant. So it is very important, the zeros which is at the end, and if there is a decimal point at the time, we have to take this zero in a significant figures. So let us take some examples here. So here the examples are like this. Now you can check here. In this case, this is significant, and according to the rule third, these are the preceding zeros, so these are not significant, and these two zeros are on the right side of a which digit? It is on the right side of the decimal point, that is it is on the right side of a number which is significant. So this 10 will be a significant figure. So how much significant figure will be here? 3. Now next example, in this example, these 3 are significant, and even this 0 is significant because it is this decimal point is there, and this 0 is on the right side of a number which is significant. And here we know that all these, so in this case there is 4 significant figures, but look at the case of this one. In this case only 3 significant figures are there, because here decimal point is not there and 0 is not there. So as you know that both these numbers are same number, but still we can say that here point 0 is there, that's why here 4 is a significant figure and here it is 3 is a significant figure. So if we take an example, that is the example for 236 number. So here if it have no decimal point at the time, 3 is a significant figure, but if I am keeping a decimal point like 236.00 at the time, what will be the significant figure? 1, 2, 3, 4, 5. 5 is the significant figure. And the same 236.0, then it is having the 4 significant figures. So as all these values are same, according to you, you know that these all values are same, but still on the behalf of the digit after the decimal point, here as it is zeros, so it can be included in the significant figures. So the values, the result for these are, it is 3 here, that is 1, 2, 3, these are the significant. Here 1, 2, 3, 4 are the significant figure, and here it is 3 is the significant figures. So these are the 4 rules we discussed for determining the number of significant figures. Now when there is numbers in the scientific notation as it is given here, so all the digits before the cross are taken as significant here. So in this case you can see here 6.09020 into 10 raised to power 4. At the time, there's no need to look at here, only just check these values, and all these values are significant here, because here 6 is significant, 9 is significant. This 0 is between the non-zero, and this 0 is also between the non-zero, and 2 is already significant, and this 0, the last 0 is significant because it is on the right side of the significant figure and because there is a decimal point. So decimal point should be there, then only we can take this 0, that is this 0 we can take it into the significant figure because there is a decimal point here. So when you check the case here, so what is the significant figures here? Numbers 1, 2, 3, 4, 5, 6. So 6 is the significant figure. In next case, here no need to check this one, just only check these values. So 1, 2, 3, 4, 5 is a significant figure. So what we can say that while measuring the numbering the significant figures, all the digits that is before the cross marks are significant. So that means all these digits are significant. Here all these are significant and here all these are significant. That is if it is in the scientific notation form. That means here the importance of determining the number of significant figure is significant figures are often used for science and measurement. They are a way to describe how accurate measurements are. So some ways of measuring are more accurate than the others. So this is the importance of determining the number of significant figures. Now let us do problem here. How many significant figures are there in each of the following? So here some examples are given here. Now I'll be explaining some examples. The rest of them you can check yourself. So here first case, 1 is significant, 7 is significant, and these two zeros are zeros in between non-zeros, that is a significant, and the last 0 is a significant because here there is a decimal point and this 0 is after on the right side of the significant figure. So this can be taken as significant number. So here total 5 significant figures are there. Now I am taking the example here, this example. The last example, when you check here, 32000000. So in this case, you can see here there is no decimal point. So if there is no decimal point at the time, we cannot take these into the significant figures. So here only 2 are the significant figures. So that is 3 and 2. These are the non-zeros. These are the significant. So these zeros we are not taking into the significant figures because there is no decimal point. But if I am keeping a decimal point here, at the time these zeros can be included in the significant figure. That is very important. If it is 32, 0, that means 320. At the time, this one is significant, this one is significant, but this is not significant. Okay, so here this one will be having only 2 significant figures. But if I am writing 320.0 at the time, because here there is a decimal point, we can include these in the significant figures. So that is the examples. Now here, how to round off to the 2 significant figures. Now questions will be given in this way also, to round off to the 2 significant figures. So if you want to round off this number, that is the first number which is given here, 2.34, to the 2 significant figures, that means as here 3 significant figures are there in this number. Now we have to change, or we have to round off this number into 2 significant figures. So that means we have to remove this digit, and this digit is actually the number 4. It have number 4. So at the time, how we round off here, just check the next number. What is 3 here? So at the time, 4 is less than 5. That's why the next digit for that will be as it is. So what will be the value here? 2.3 as it is. But when we take the next example, in the next example, 2.37. What is the significant figure for this one? It is 3. But we have to take this into, we have to round off to this number into 2 significant figures. So how we round off this one? 1, 2, 3. Here 3 significant figures are there. So we have to remove this last digit, that is 7, that we have to remove from here. Now check, the 7 is greater than 5. At the time, the neighboring number will be increased by 1. That is, it become 2.4. Now the 2.4, its a significant figure is 2. So that is what the question will be asked, to round off to the 2 significant figures. Now in this case, the example this is given. In this case, because it have how many number of significant figure according to this number? 1, 2, 3, 4, 5, 6, 7 significant figures are there. So we have to round off this one. And in order to round off this one, only we need first 2 digits only we need. So we have to remove the rest of the number. So you can see only we needed 2.3. And what is next to that number? 4 we have, then 9 we have, 8, 6, 5 and so on. So here, we need only this much. So check this number. You have to check this number 4. 4 is less than 5. So this number will be as it is 2.3. But if it is 6 here at the time, this one will be 2.4. So that is what this question. And in order to such type of numbers, better to convert into the scientific notation. So already when we convert in the scientific notation, now you can see that it have only 2 significant figures. So such examples can be better converted into the scientific notation as it is done in this case and in this case. So here there are homework for you, that is a NCERT text questions. The question is, express the following in the scientific notation. That is you do it and find out the significant figures and calculate the significant figures in the following. So here in this case you have to find out the number of significant figures in the following. So these are very quite important, because in the exams usually the question will be asked to find out the significant figures in a given number. So all of you practice well these type of question. So this is all about this video. Have a nice day.